Alright, good morning again and welcome back to Garage Science. So we're going to make something for the mill with the mill today. And what we're going to make is this. So what this is the tool holding fork for the automatic tool changer for the PCNC 440. Now Tormach obviously gives you some when you buy the tool changer. And what those are these plastic, it looks like probably glass filled nylon plastic tool holding forks, and they do that I think for a couple reasons. One, the tool holding forks a little over a semicircle, so that way when you go to clamp a tool in, it actually detents in there and is held in place. The other part is along with the nylon screws that hold it into the tool changer carousel, is if there's a misfeed on the tool, you're not going to damage the tool changer. You'll simply push the tool holding fork out of the carousel, or you'll break the fork. So kind of a planned failure mode there, which is good. You need that. But from my experience, when the mill misfeeds a tool, it strips the nylon screws out of the carousel before anything else. But what I have noticed is that the tool holding fork will sag a little bit over time, especially if you do things like I do occasionally and you leave the tools in the tool changer for an extended period. They will sag over time just a little bit, and you don't need much. There's not a whole ton of play when the mill head comes down to get the tool. And so what you end up with is these tool holding forks will eventually not be flat, and so when they sit there, instead of the top of the tool head pointing straight up, it'll cant out slightly, and then if there's just a little too much resistance in the mill head coming down, then it'll just push it down even further. So either your tool won't go all the way up into the spindle, and then you'll probably ruin whatever you're milling, or it'll just misfeed the tool entirely and either drop the tool off the carousel, or you'll start milling without a tool. So anyways, we're going to fix that with an aluminum tool holding fork, and then I've also got this 3D printed detent jaw on here, right? So if you mill past a semicircle on the tool holding fork out of aluminum, then you're not going to be able to get the part in, because aluminum is not going to flex like the nylon tool holding fork. So I've 3D printed a detent on there that actually holds the tool pretty well, right? So it actually snaps into place there, doesn't fall out. It's connected on the back side, so there's a spring-loaded action there with the tool holding fork detent arms. And then yeah, so anyways, we're gonna make a bunch of these and we'll see how it goes. So what we did now is we just spot drilled our holes that we're going to drill on the top. So 2 of those are going to be 6mm holes. That's going to be for the nylon screws that hold the tool holding fork into the carousel. And then the second 2 will be 5mm holes, and we'll tap those. That'll be for the detent arms. Alright, so what this is a 1/2 inch end mill. What we're using a volume mill tool path off of SolidWorks. And so what that's going to do is cut the entire perimeter, all of its features. And I believe this tool path is about 9 or 10 minutes. So we're done with the volume mill tool path. We're facing off the top now. That'll one, give us a flat surface to flip over and do the other side, and it'll make it look a little nicer. I don't have a shell mill or a fly cut or anything else like that, right? Otherwise I'd be using that to face off the top. So we're just using the end mill. Alright, so we're done facing. Now we're going to do a contour around the overall perimeter of the part. That'll get us our final sidewall tolerance. Alright, next we're going to cut the ledge for the Tormach tooling system tool holder. So I turned down the feeds and speeds on this. Probably could turn it back up. I just haven't taken the time to do it. Now this is going to be the final pass. There's one more spring pass. There's a setting in SolidWorks that allows you to set the final feed rate as a percentage of the original feed rate when you're doing a contour mill. And I didn't realize when I posted this it was set to 17%. And so we're going a whole 70 millimeters a minute right now. So it's just a little painstakingly slow. And then there was also set to do 1 spring pass. So after we do this pass, there's 1 more pass to do at this feed rate. So it's it just takes a little second. So it's a good example why attention to detail before you post matters. Alright, so that's it for the 1/2 inch end mill. We're going to do a little cleanup work now. So going back to the spot drill, what we're going to do is we're going to just tap the, just barely kiss the top of our holes that we drilled, just to put a chamfer on the diameter. Got to have our part look a little nice. And then finally we're going to go around the perimeter of the part with a chamfer mill. That'll help clean up any burrs that maybe exist there. And we'll put a nice little chamfer on the side. Alright, and that's it for op 1. Not a bad first op. Looks pretty nice. Something I like to do is just take a old paintbrush, preferably without paint on it, and in between ops I just take some of the chips and brush them off the bellows for the way covers. You can build up enough chips on the way covers where they won't compress properly, and so I just like to brush them off in between operations. Alright, so next we're going to flip it and we're going to cut the hat off, mushroom top, whatever you want to call it. So in order to do that, we're going to center it on our jaws. So we're going to center this on our jaws, and in order to do that, we're going to use a 3D printed fixture, like so. So what this does is it sits right on the jaw, sits pretty tight, and so what that allows me to do is get this centered. So we're going to put the rounded edge on the back jaw, and then the 2 forks will press against the front jaw. Now what you'll see when we do the tool path is we're going to come down and we're going to cut in only the positive X direction, going that way. So we'll cut our tool diameter cut will be in the negative Y direction, and then the tool path will be in the positive X direction. And what that should cause is, as we climb mill, it should continue to push. The cutting force should be towards the moving jaw, and it should push the 2 forks into our other jaw. That should be the primary direction of the cutting force. And what that should do is it should keep it level, because I don't want this to shift with the rounded edge in the jaw. So that's one purpose of the 3D printed fixture, and that should help us get a nice centered, flat final cut. And so what we'll do is we'll do 2 passes. One will be a heavy cut, and the next one will be a lighter cut. And what we'll do is we'll pause in between. So that way I can take a dead blow hammer to the fixture and make sure that we're still flat. If you're not familiar with machining, the spiral flutes on the end mills, we'll actually try and pull the part up out of the vise. That's another direction for the cutting force. And so before we make our final cut, since we want it to be perfectly flat, get a nice really good finish on it, the final cut will only be 1/2 millimeter deep. So we'll take off nearly all of this on the first pass, and then we'll unclamp, reclamp it, make sure it's settled completely flat, nothing shifted, and then we'll take that last 1/2 millimeter off so we get a nice smooth finish. Despite not having a shell mill, face mill, or fly cutter, we'll still get a pretty good finish even with the end mill. So this was a programmed stop that I just inserted in there, one, so I could remove this flashing, and two, so we could unclamp and reclamp the part into the vise to make sure we're nice and flat. So this flashing will basically just flap around as the end mill goes across one more time. And I'm not a tool life expert, but I'm pretty sure that's bad for tool life. Someone in the comments can probably confirm that. Yeah. That one there. It'll be cut up pretty easily. Okay. Nothing fancy. I don't know if it comes up on the video. There's some ridging that you can see on the surface of the part from the tool passes. It's not real bad. It's not the final finish on this doesn't really matter for the aesthetic's sake. You just want to make sure it's nice and flat when it screws into the tool changer carousel. But it is noticeable. So this final pass will help make it look much nicer. We're going to cut air for a minute until we recontact the part. So this is where we stand post op 2. So in order to do op 3, we're gonna keep it on this side, but we're gonna add a little standoff so we can actually machine the final ledge. So we're gonna come in and we're gonna machine a ledge here. So when we put the detent arms on, it'll have kind of a ledge to sit on, so that way over time it can't like sag down and misalign with the rest of the tool holding fork. So because we're clamping to this rounded edge in the back, and you maybe even saw when I took it out, but there's a little bit of a dent in my nicely machined aluminum vice jaws here, and that was unfortunate. But that's because when you go to clamp this, right, it's pressing in on only one point, and so there's just there's a lot of pressure there, and so it deformed the aluminum jaw just a little bit, which thankfully this top surface isn't as critical as the back surface, and a little rounded deformation there is not going to kill it. So alright, that'll be enough to do the rest. I might even and we're just going to cut it dry so we can see it without the coolant. Now I do have to probe. So I do have to probe off of this front corner of the part. Actually, I just realized I forgot to take a file to that. So we're going to unclamp this briefly. Alright, so what we got here is the homemade touch probe, and all it is a precision ground rod of aluminum with a wire attached to it, and it's electrically isolated from the rest of the spindle on the mill, and there's a multimeter hooked up to it with on the continuity setting. So what's going to happen is it's going to beep once it touches. And then I can zero that axis. I'll add the offset for the radius of the probe once we're done here. But you know, probes are not cheap, and I'm a cheap guy. This probe cost about $3 to make. And it works pretty good. I've machined things to within a thousandths or a 10,000ths of an inch probing with this probe. It does all right for itself. It requires a little extra effort since there's no automated probing routines. We're going to go ahead and add, so all you got to do is go to the work offsets page in PathPilot, and we'll just add 4.7625 millimeters to the X and Y to shift our 0 to be the center of our probe. So I always do a dummy check whenever I do this, and we go to X0, Y0 manually, and there we go. We're centered. The probe is centered. So we're done now. Alright, so we'll go ahead and we'll get going. I'm going to cut this dry. I'll go ahead and turn the coolant off. There's not much to cut here. So the reason I always move the table out of the way whenever I change a tool, that's something that I add in after posting, is once you have longer drill bits in there, it is possible to have the tool changer hit either the vise or your mill part when it comes in to make the tool change if you don't move it out of the way. And this is a smaller part, so it's not really at risk, but it's just a standard thing that I do every time I post something, is to add a line in there to move the table out of the way every time I do a tool change. So we're coming and kissing the other side of the holes just to put the same chamfer on them that we did on the reverse side. And that's it. So we went from raw stock to finished part. I still have to tap these, but we'll do that here in a minute. There's just a tiny little bit of flashing there, down in the corner. You can basically get it out with your fingernail. But I'll take a file to that just to make sure that's rounded over nicely. But that'll fit nicely, and we'll put the 3D printed detent on next. So there's the rest of the pieces we need for this, straight off the printer. Go ahead and remove all the support material. Alright, so that's going to be our detent arm, and these are the bushing. So I printed 4 with this. You only need 2. Figure 2 are extra. They'll slide in there. So what that'll do is one, they're slightly thicker than the detent, so when you screw down, the screw won't fully contact the detent arms. It'll be stopped by the bushing, and then it'll obviously rotate inside the detent arm. So this slip slides in underneath the ledge like that, and so what that does is it keeps the detent arm from warping and deforming in that direction downward over time. So it should keep it running smoothly for a good while. So these are M6 screws. They're button head Allen key screws. These ones are stainless steel, so should last very, very long. So not hyper tightening them, just a little bit, and you see I still get a nice detent spring action in there. So the curvature here, one, conforms to the inside curve of the tool holding slot, but it also allows a little bit of flex up there, so you get a spring action. Works pretty good. And it snaps right in. But it's the same size. It's the same size as the original detent arm. So it should just take its place. Something I have noticed is that it seems that I've probably adjusted my tool changer to accommodate the sag that the tools have in the plastic tool holders, because it seems like the aluminum forks in there, the tools are kind of hanging at a little bit of an angle. So I'll probably end up having to adjust the the tool changer alignment just a little bit once I get all these tool holding forks replaced. But that'll be the next step. Alright, so we've got 4 of these done now. There's 3 here, there's 1 I already put on the tool changer. And so we're halfway done. There's 8 total tool holding forks, but 4 is enough to convert over from the plastic original tool holding forks and go to the new ones. And I can still hold plenty of tools in there while I finish the remainder of the tool holding forks. So we're going to go ahead and make that swap now and see how it goes. I've already got 1 of the tool holding forks up here, but we'll go ahead and pull another one off. It's kind of obvious how to take these off, but we'll put it on camera just so you can see. So these are just like nylon plastic screws. I wouldn't recommend using a socket wrench to take these on and off because they really shouldn't be that tight. They're meant to fail in the event the mill head crashes into the tool changer. So you just break a couple of 5-cent screws in your $3,000 tool changer. You want to make sure there's no chips or anything there that would impede us from getting a flat mate between the new tool fork and the old, or the tool carousel. Again, you don't want to probably use a socket wrench to do this. It does not take much to strip these nylon screws, and they really only need to be hand tight. Just a little bit of torque behind them to make sure they are snug. And then that's all you need. Yeah. Detent still work just nicely. Alright, on to the next one. That's all 4 of them. Let's see if we can't get the tools in there. Alright, so got this all set up now. Took a little bit of finagling with the tool changer. I had to adjust it slightly. So probably because the tool forks, the old tool holding forks, I had a little bit of sag in them over the past year or so that I've been using them, and I kind of slowly adjusted for that, and now I had to adjust everything back. And then I ran into a couple of things that I didn't really expect. So one of the things that I did was adjust the travel on the tool changing tray, and as I did that, I moved the nut on the actuating piston to move the tray further in, and I started getting this weird error from the path pilot saying basically the tray had not arrived, saying the sensor didn't detect that the tray had arrived after it had moved forward. And so I put the nut back after reading some stuff on the Tormach forums, and that cleared that error. So it was basically over traveling is what it looks like. And so I went back to the mounting nuts and did a quick little couple measurements on it, and basically it was a little further from the mill column on the front 2 nuts than it was on the back 2 nuts. So basically everything was angled that way, right? So I was having to cause the tray to travel further in this direction in order to account for that. But it was a pretty big difference. It was only about 0.5 millimeter difference in length in the back, and that caused enough of a kind of travel distance over here. It was probably like 3 to 4 millimeters extra travel distance that I needed here. and that was caused by half a millimeter's worth of offset in the back. So anyways, it's because the those mounting bolts are relatively close together, just kind of the nature of the beast, and so any small adjustment back there has a much bigger effect up here. So that's just something to watch out for. It's an odd area that doesn't immediately point you to what you need to do to fix it, and so if you run into that, that's what you got to do. By the way, if you don't have one of these, you should make one. So there's a 3/8 inch set screw tool holder, and it's got a 3/8 inch stainless steel rod in it, and that is great for aligning your ATC to make sure that it is perpendicular. And so if you don't have something like this to stick in there, you should make one. But now, the moment we've all been waiting for. I'm going to go ahead and store this tool. Hey, look at that. Voila. So we've got 4 set up now. Still got to mill the last 4, but we can start using the new tool holding forks while we make the rest of the tool holding forks. But that's something I'll do on my own time. I think this video kind of covers everything I wanted to show here. It's a good little project to improve the quality of the mill. It is important to remember that you have to keep the nylon screws. Don't replace those with metal screws. It's meant to be a plastic screw, so it can fail if you crash the mill into the tool changer. I could imagine the torque on the mill head is plenty to damage the tool changer if the tool holding fork can't fail by breaking off the carousel. So yeah, make sure you keep those nylon screws. Don't think you're outsmarting the system by making them metal. But anyways, if you haven't subscribed to the channel, make sure you subscribe, and we'll see you guys later. Let me know in the comments everything that you think. Alright, see ya.